The humanoid robot pipeline is based on humans. The reason we have humanoid robots is because we want to learn from humans. We have one instantiation of a robot in the real world, and that is the human, the biological intelligence, which is moving around in nature and acting. And what we want to do is we want to learn from humans and create an artificial intelligence that can move around in the real world. For that, we have to use the frontier pipeline that is pre-training, mid-training, fine-tuning, and most importantly, we want to create world models. However, the way we see it here at Orange Capital Partners, it's exactly the inverse of what the industry is talking about right now. Currently, the industry is talking about creating world models that then can be used to train robots. We see it the other way around. The robots will train the world model. So it's actually exactly inverse, that we need robots, agents, to act in the real world and collect the actual data that the robots produce while acting in the real world. So actuator data, proprioception data, vision data, and then move that into a world model, create a world model, and then use that to create a flywheel for learning. This is not in our own podcast. It's May 16, 2024. This is Krim Delco. For the year, we're up 0.5%. The market's up 8%. We're underperforming by 7.5%. So the industry is incredibly excited about world models, and there's some heavy-duty academics that have created businesses around world models. And we spoke about this in the previous episode where we compared those with Waymo and Yahoo. So I'm not going to go into details about why we think that these people are wrong. They're not actually wrong. They're just too early. The idea of a world model is a good idea. It's just the way we want to train those world models. I think they got it wrong. Instead of creating the world model in digital space and then transferring that somehow into real space, we see it the other way around. We learn from humans. By the way, that's why we have world models, humanoid robots. It's because we want to learn from humans. And then once the robots can perform actions in the real world, we train them in an unsupervised, experienced way. So that means that they're not fully precisely developed into delivering goals, but they are taught, and this is piggybacking on Andrew Wagenmaker's work. What we want to do is actually train our digital embodied agents to explore in the real world, and then we collect that exploration data and feed it back into a world model. So the world model is trained on the actual robots, and then with that world model, we can train new robots, and then we can create a flywheel. The importance of having actual robots moving in the real world, it's very similar to humans when you learn how to surf or ski or do jiu-jitsu. You can't learn that from video. You have to actually do it yourself in order to have the muscle memory to produce the movements necessary to perform a task. The mathematics of surfing a wave are so complex. There's so many degrees of freedom. It's almost impossible to capture this, at least not with our mathematical tools currently. So what we're doing as humans is we function approximate through a neural net, our fiber networks in the muscle. We call it muscle memory because the memory is actually in the muscle themselves. And I think very similarly, we need agents to do the same thing and then feed that data back into the world model. So what we're saying here, and I want to make sure, we're not saying world models are obsolete the same way where we never said full self-driving cars are obsolete or internet search is obsolete. What we said is that Yahoo was early and Waymo was early because they chose the wrong technological path for, in both cases, just simply because they were early. Maybe Yahoo wasn't early, they just chose the wrong path. Again, I discussed this already, I don't want to repeat myself, but when you're on the wrong technological path, when the path is wrong, no matter how much money and intelligence you throw at the wrong path, it's not going to yield better results than another company or another group of people who actually choose the right path. And the right path, in our opinion, is exactly what Elon Musk said that they're doing with Optimus. Now, whether they're doing it or not, that's a different question. And of course, there's always execution risk. But the idea is that to train Optimus is exactly the same way that FSD has been trained, which is you first start with human data. You collect billions and billions of hours of human data, which we have. So let's talk about FSD, and then I'll transition into Optimus. So FSD was trained on billions of miles of human driving, and most importantly, that is video and actuator information in one. So this is in latent space, we have scene and we have, state and transition functions defined. That's what end-to-end learning means. What end-to-end learning actually means is that you have the state and transition functions defined in latent space during pre-training. Then the mid-training in the case of FSD is something along the lines of training the car to transition, let's say, things like train overpasses and all that kind of stuff, like all the more skilly, difficult stuff. And then fine tuning is have the car actually behave like a human. So now let's transition to Optimus. How is Optimus going to be trained? It's going to be trained from billions of hours of human video, and that's why we have humanoid robots. I think this is very important. We don't actually are building humanoid robots because the world is built for humans and stuff. That's part of it, but the main reason we build humanoid robots is because we have data. We have actual morphology of something that we call human moving around in the real world. So we have information about how something that looks like a human acts in the real world. Now, the task from transitioning human action videos into robot action in the real world, that's not an easy task. And people are working on it. Trevor Darrell working on it, Sindra Malik and others. And we believe that that is actually the future of robotics. And the only hope we have to actually have a scaled AI in the real world is that we can build that data flywheel. But we have to start somewhere. We have to bootstrap somewhere. And the bootstrap is going to be human videos, internet scale videos. Then the morphology gap has to be closed from those human videos to the humanoid robot. And this is where Andrew Wegemacher's interesting work comes in. What we want to is train the robot to explore in the real world. Because what we want is, we want an unsupervised reinforcement learning approach where the robot explores in the real world how to pursue goals. So develops tasks to pursue certain goals. In order to do that, we need to have, that's why we need the pre-training, because we can't have the robot in the real world doing random things. That's too expensive. It would take too long. We believe that after billions of hours of pre-training, the robot will have enough understanding of the real world, will have enough understanding of how to explore, for example, how to screw a screw, how to open a door, how to clean an apartment. And then we can, in mid-training, train the robot through even supervised reinforcement. We can even throw in some reward functions here. The key is that once we have a base, we can then have the robot explore in the real world how to pursue goals. And that data, which is then similar to the FSD data, that data will be states and transition functions directly in latent space as attached to the actuators that are relevant for the specific goals. That data gets then fed back into a world model, and then the world model is a real world model because it's trained on the real world. That's the key. Now, there are people like Moonlake AI and World Labs and so forth. Like, they're all trying to do, in our opinion, what Waymo did, like some sort of Frankenstein world model that maybe in the short run can work. But we believe that in order to capture the bitter lesson at full scale, our approach is more palatable. So we start with video learning, pre-training, mid-training, fine-tuning. We feed data back into the world model. The key is that the robots Once they're in the wild, they learn how to explore, and that particular exploration then helps the robots train themselves to become better at pursuing goals. Now, the job of the researcher, the job of the engineer, the company that is actually building these machines, is to define the right goals and, of course, also create the kinds of algorithms and hardware necessary for the robots to deliver against this architecture. Now, that, of course, is way beyond the scope of this episode. But I think what's important here, and I just want to lean back for a second, give people some perspective. The purpose of this podcast series is to give people a sense for what it feels like to run a hedge fund. We're highly invested in real world AI. And I think this is a very good example of what it actually means to create wealth as an investor. It's to have an understanding of what the path is. So I think we have a pretty good understanding of the path. And it's our job now to put the capital in the right path, or in other words, invest in companies that are on that path. And that's what we're doing with Tesla and NVIDIA. NVIDIA is more general. They're betting on several horses here, and we believe NVIDIA is a sort of general purpose AI company, and that's fine. Tesla is very specific. Tesla is betting on exactly this path. This is also why we're inspired to even think about this, is through what we've seen and heard from Tesla. But more importantly, also, we are seeing a convergence now in the academic community towards that. We also see the flaws of, let's say, these world model companies. They are, by the way, that doesn't mean they're useless or wrong. I think Moonlake AI has some use, particularly for companies like Tesla. They're using Moonlake for edge cases. There's a lot of synergies between the current world model approaches and companies like Tesla. By the way, Tesla itself is the kind of company that, because they have this very strong real world AI, they are kind of already able to do exactly what we're saying should be done, which is they can use their real world data from the FSD and feed it back into a world model, and then train that world model based on that real data and create scenarios that then can help Tesla generate more edge cases. So it's possible that they're already doing that. But the point of this episode is to, again, give a roadmap, give a certain path. So for investors, it's valuable to know the path. So for example, also where not to invest in, and you know what to expect from your portfolio companies. Thank you.